Good morning. It's November 11th and this is your daily brief in science. Here's everything you need to know. A landmark campus partnership unveils a new IonQ Center at the University of Chicago, pairing a next-gen quantum computer with an entanglement distribution network for campus-wide research access. The collaboration aims to advance quantum hardware, networking, sensing, and security with applications in chemistry, materials science, optimization, and advanced communications, aligned with IonQ's roadmap. UChicago quantum faculty will receive ongoing support intended to generate intellectual property that could drive IonQ's product portfolio and long-term growth. The press release notes forward-looking statements and risks drawn from IonQ's SEC filings, cautioning readers about uncertainties and financial disclosures. The alliance positions IonQ to expand its visibility and market position, with recognitions such as Fortune Future 50 and Forbes' most successful mid-cap companies cited. Key figures highlighted include IonQ Chair and CEO Niccolo de Masi and University of Chicago President Paul Alivisatos, underscoring the strategic importance of the alliance. IonQ targets industry-leading quantum computers, Tempo and Forte Enterprise, and aims for 2 million qubits by 2030 to accelerate drug discovery, materials science, financial modeling, logistics, cybersecurity, and defense, while expanding quantum networking and the quantum internet. The program highlights commercial-grade systems and partnerships with major cloud providers, alongside a long-term goal of a 2 million qubit system. Achievements cited include a 99.99% 2-qubit gate fidelity in 2025. The initiative aligns with Illinois as a growing quantum innovation hub, referencing the Illinois Quantum and Microelectronics Park ecosystem. IonQ describes the partnership as foundational for fueling real-world innovations through a mix of commercial systems and academic collaboration. The project expands Illinois' quantum ecosystem with a fiber quantum testbed linking UChicago, CQE, Argonne, and Fermilab, enabling applications like unbreakable encryption and distributed quantum computing. It could seed more than 140 research and development projects across UChicago and extend to national labs, universities, and industry partners. The November 2025 prospectus filing allows the University of Chicago to resell its IonQ shares under the earlier registration rights agreement, and IonQ filed a prospectus supplement on November 10, 2025, to cover the resale of over 2 million IonQ shares by the university. A new dating method uses uranium-lead dating directly on fossil eggshells, treating eggshells as natural geochronometers by mapping trace uranium and lead in calcite. This approach aims to date fossil sites without volcanic ash layers, potentially unlocking precise timelines for dinosaur evolution and paleoecology. The technique argues that eggshell calcite can provide age determinations at ash-free sites, expanding the toolkit for deep-time reconstruction. The study, published in Communications Earth and Environment, includes co-author Lindsay Zano and is supported by the National Geographic Society. Researchers acknowledge it is early stage but show promise for improving age assessments at ecosystems and evolutionary questions lacking ash layers. Lead researcher notes that using multiple dating tools strengthens the reconstruction of accurate timelines for ancient life. Future work will refine how eggshells incorporate radioactive elements and establish reliability checks, with ongoing support from the National Geographic Society. The method could benefit other egg-rich sites without volcanic ash, such as South Africa's Elliott Formation and Patagonia's Alcamahuevo, enhancing understanding of dinosaur evolution and ecosystems. Eggshell dating can be as reliable as, or more reliable than, traditional methods when ash layers are missing, according to co-authors who describe direct fossil dating as a major advance. Tests in Utah and Mongolia showed dating accuracy within about 5% of precise volcanic ash dates, with Mongolia yielding the first direct age for a locality preserving dinosaur eggs and nests around 75 million years ago. In Mongolia, the Teal Ulan Chaltse eggs were dated to roughly 75 million years ago, placing those dinosaurs in the late Cretaceous, and the locality represents the first direct age for a site preserving eggs and nests. The accompanying article is titled UPB Calcite Age Dating of Fossil Eggshell as an Accurate Deep-Time Geochronometer and was published on November 10, 2025. This technique complements bone and tooth dating and can overcome limitations when zircon or apatite are absent at fossil sites. Overall, the method adds a flexible dating tool for ash-free sites with potential to transform cross-time and cross-region paleontological correlations, as led by Dr. Ryan Tucker. The international collaboration spans the United States, Mongolia, Brazil, and South Africa, with fieldwork supported by MADEX, the National Geographic Society, and the National Science Foundation. In Utah, Oviraptorosaur eggs between ash layers dated to about 99 million years yielded uranium, and lead dates around 97 million years, aligning closely with ash-derived ages. A new intranasal pertussis vaccine from a Trinity College Dublin team aims to block infection at the entry point by delivering mucosal immunity directly in the nose. The vaccine uses antibiotic-inactivated Bordetella pertussis to preserve key structures and epitopes, driving local T-cell responses and nasal IgA with limited systemic inflammation. After vaccination, researchers observed an increase in THOD17 and T1CD4 positive T cells in the mucosa, boosting barrier function and microbial clearance, with tissue-retaining T cells supporting longer-term immunity. The delivery is needle-free and aerosol-like, focusing on a T-cell-driven response rather than relying on antibodies alone. Protection in preclinical models is tied to local IL-17 and IF and gamma-producing tissue-resident memory cells and nasal IgA, with superior nasal protection compared with current vaccines. Compared with whole-cell vaccines, AIBP induces stronger mucosal IgA and TRM responses, while whole-cell vaccines yield higher systemic IgG but less mucosal protection. The platform is described as programmable and adaptable, with ongoing work to determine how durable the mucosal memory is, when boosters are needed, and the optimal delivery site in the respiratory tract. The approach targets respiratory mucosa to achieve protection without systemic inflammation, potentially interrupting transmission and broader community spread of pertussis and other respiratory pathogens. In mice, 2-dose aerosol regimens achieved sterilizing immunity in both lungs and nasal passages, and single-dose vaccination also provided substantial protection, with lower bacterial loads after challenge. Safety signals in preclinical work show limited systemic inflammation and no colonization of the respiratory tract after delivery. If translated to humans, this mucosal T-cell-driven immunity could block transmission and contribute to herd protection, reshaping next-generation vaccines for pertussis. The findings were published in Nature Microbiology in 2025 by Kingston Mills and Davud Jazayeri, with the D01 10.1038/S41564-025-02166-6. A new study in Science uses dust in Arctic sediments to reconstruct 30,000 years of central Arctic sea ice cover, linking ice presence to lower dust deposition. Researchers separated cosmic dust from terrestrial material by measuring helium-3 in sediment layers, helping identify periods of year-round versus seasonal ice. Thorium isotopes in ocean sediments were also analyzed to distinguish cosmic from terrestrial dust and infer past ice conditions. The study weighs two explanations for Arctic nutrient dynamics, leaning toward higher productivity from more photosynthesis during reduced ice, rather than nutrient dilution from ice melt. Findings suggest future Arctic ice loss could boost nutrient uptake by surface organisms, with potential effects on the Arctic food web and fisheries and broader ecological and geopolitical implications. Nutrient cycling analyses, including foraminifera shell records, show phytoplankton drawdown of nutrients peaks when sea ice is low and wanes as ice builds up. Overall, the link between ice coverage and nutrient dynamics implies shifts in Arctic food webs as melt progresses. The data indicate perennial ice during the last glaciation, a transition to seasonal ice in the warm early Holocene, and a later increase in ice cover. As sea ice declined at the end of the last ice age, cosmic dust deposition rose, signaling more open water, with similar patterns in the late 20th century retreat. 3 sediment sites across a gradient of modern ice cover show year-round ice corresponds to less cosmic dust, while open water periods allow more dust to settle. Space dust data provide a valuable new tool for studying the Arctic Ocean, a region less understood than areas accessible by satellites. A new clinical trial presented at ASTMH 2025 in Toronto shows ivermectin can be safely given to very young children weighing as little as 5 kilograms, widening eligibility for mass drug administration against neglected tropical diseases. The study aims to reassure regulators and manufacturers about safety in children under 15 kilograms, addressing prior gaps and potentially expanding MDA campaigns. Building on a prior systematic review, the trial seeks to support broader inclusion of smaller children to reduce disease burden and transmission. Removing weight-based barriers could accelerate control of onchocerciasis by enabling earlier intervention and potentially reducing immune-related neurological complications. Beyond treatment, researchers see potential health gains when early ivermectin use is linked with nutrition programs and malaria vector control. Endorsements from the American Society of Tropical Medicine and Hygiene and its leadership add weight to the study's implications for science and global health policy. Broader eligibility could reach more children, supporting MDA and accelerating control of multiple neglected tropical diseases. Lead author Kevin Kobylinski notes that including small children in MDA could substantially reduce disease burden, with potential to influence malaria transmission when coverage nears 70%. Widening eligibility could reduce scabies transmission, given the high burden among children and close contact dynamics. The trial employed robust methods, including double-blind randomization and multi-site monitoring, conducted with Mahidol Oxford Tropical Medicine Research Unit to support generalizability. Expanding use to smaller children could improve outcomes for intestinal helminth infections by addressing malnutrition, stunting, and cognitive impairment linked to chronic infection. Reducing treatment exclusions may enhance malaria control, as ivermectin can lower transmission by affecting Anopheles mosquitoes, especially with broad MDA coverage around 70%. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.